All right, welcome back everyone to Wisconsin Water Week Day 2 of the Fisheries portion. We've already heard from two amazing speakers this morning. I hope you were able to join us for those. And we're going to move right along. We've got two more speakers today. We'll be hearing from Brad Sims right now at this moment, and then we'll be hearing from Dr. John Lyons a little bit later at 11. I'm going to introduce Brad here briefly. Brad has worked over 22 years as a fisheries biologist with Wisconsin DNR. And during that time, Brad has spent many hours surveying, studying fish fauna of the driftless area in southwest Wisconsin. His favorite resource to work with is the lower Wisconsin River. And when Brad is not spending his time with his wife, two sons, and their family dogs enjoying many of the water resources in southwest Wisconsin. So Brad is here to tell us a little bit more about some interesting fish and fauna of the lower Wisconsin River system. So I'm excited to hear your presentation, Brad. And with that, you are more than welcome to take it away. Actually, the one housekeeping item, if you have any questions throughout the presentation, I forgot to mention this, make sure to send those questions in through the Event Mobi platform. I will be monitoring those throughout. And then make sure to vote on your favorite question or a question you might think is most relevant. That way I know which ones to prioritize with the time we have at the end of Brad's talk. So, all right, with that, Brad, you are more than welcome to take it away. Thank you for being here.
All righty, thank you, Luke. Just a quick sound check. I sound okay?
Sounds great.
All right, thank you very much. Well, thanks for attending my talk. And like Luke mentioned, we're going to be talking about the interesting fish fauna of the lower Wisconsin Riverway system. And so hopefully it's really not a research project, more of an informative talk. So hopefully folks will get to see something that they don't normally get to see or hear about. One thing I would like to kind of mention as far as the two takeaways is, number one, the number of fish species that we have in Wisconsin that we don't normally get to see. I'd like folks to take away from this presentation. When you look at the picture here on the slide, normally when I give these types of presentations to conservation organizations or school groups, I'll ask, what do we see out in front of us when we're standing streamside? And we'll see the trees and the sun and the clouds and the sandbars and the water, but we normally don't get to see all the different fish species that are swimming underneath the surface of the water. And another takeaway from this presentation today is, even though we're going to be talking about the interesting fish fauna of the lower Wisconsin Riverway system, being Water Week, the lower Wisconsin Riverway system itself is the star of this presentation. When you look at the diversity and the complexity and the interactions of all the different water systems that make up the lower Wisconsin Riverway system, that's what's leading to all the different fish species that we have here with that. So to get started, we are going to talk about the lower Wisconsin Riverway. For those that aren't familiar with the lower Wisconsin Riverway, it's located here in southwest Wisconsin. It flows approximately 92 miles or covers approximately 92 miles of stream thread, just over that, from Prairie du Sac down to the Mississippi River. The lower Wisconsin Riverway that we'll be talking about today and all the different fish species associated is not only comprised of the river itself, but also all those diverse and complex wetlands, streams, backwater lakes, and sloughs, et cetera, that go along with that. So to understand the lower Wisconsin Riverway itself was created in 1989 by the signing of Act 31. It's approximately, the lower Wisconsin Riverway boundary is approximately 95,800 acres. Of that, somewhere in the neighborhood of 45,000 acres are public, and it's slowly growing today as we speak. We're still doing some land acquisition within the lower Wisconsin Riverway. And then in 2020, 44,000 acres were recognized as wetlands of international importance, which was really cool as well. So we're talking about more of a system here than just a river. So where does it begin? So I'd mentioned it starts up here at Prairie du Sac, where there's the dam. There's the hydroelectric power plant at Prairie du Sac, the dam at Prairie du Sac, which creates a large scour pool. This is the beginning of the lower Wisconsin Riverway, or the lower Wisconsin River, so to speak. And this scour pool adds to the habitat diversity. It's kind of lake-like. It's somewhere in the neighborhood of 40 to 45 acres, depending on water levels, and it'll be somewhere in the neighborhood of 30 to 40 feet deep, also depending on water levels as well. So with that, you go down from the dam, down about 7 to 8 miles or so from the dam, we get this gravel, limestone, large rock substrate that we'll see along the lower Wisconsin Riverway. So from the dam, where you see in the picture here, 7 to 8 miles down, we'll have a little bit different substrate, which helps add to the diversity. And it's also an area where we see a lot of our spawning, where we have that rock and gravel substrate. So 7 or 8 miles down, you get down towards on the map, the Arena or Mazo area. This is where you start getting into the typical lower Wisconsin River that we think of when you hear lower Wisconsin River. And that's going to be where your substrate turns from that rock, gravel, limestone type substrate to a sandy substrate, where you get the sandbars and you start to get the braided channel river that we think of when you hear the lower Wisconsin River. And that pretty much all continues the rest of the river until we get down to the Mississippi River itself. Empties into the Mississippi River, joins the Mississippi River down by Prairie du Chien, which is near Bridgeport or Wyalusing State Park. This is another reason we have such a diverse fish fauna on the lower Wisconsin River system, because it does tie into such a big riverine system such as the Mississippi River. So continuing to look at the habitat diversity of the lower Wisconsin Riverway, again on the left we think of the main river channel of the Wisconsin River when we think of the lower Wisconsin Riverway. But really what sets it apart and makes it unique and special is all that diversity and complexity and the interactiveness of all these different water resources that we have. On the upper right, we'll have all kinds of vegetative sloughs and natural lakes. We also have some lakes created by people activity in regards to digging out for the railroad trestle, and then also some bridge projects from DOT. But then we also have a lot of flowing streams and interconnective channels like you see on the bottom right as well. And so these all tie in together for a much larger aquatic ecosystem and wetland system that we'll see within this area. And not only in the floodplain of the lower Wisconsin Riverway, which contributes to this, but also out in the watershed where we get the driftless area coulee hills and the groundwater flows and the springs that come down to the springs and the spring streams, both warm water and cold water streams, and the tributaries that traverse the lower Wisconsin Riverway floodplain coming into the Wisconsin River itself. They also kind of contribute to the habitat diversity as well. And so with this habitat diversity, I guess I'm getting ahead of myself here. To continue to look at the habitat diversity, the aerial photo that we have here kind of shows you the main river channel up to the north or the top side. You'll see the main Wisconsin River channel where we have the sand substrate along with the braidedness that you'll see, the islands, the bottom hardwood forest. And then also just to the south of that, you can kind of get an aerial view of the side channels and the wetland, the sloughs and lakes, and also the side channels that you'll see that go along with the lower Wisconsin Riverway. And to kind of get a better idea of the diversity, if we overlay the water, the surface water data viewer, if we overlay the waters layer on that, it kind of gives you a better idea of the complexity of it. And then on the far south edge of that, where you kind of see where all the sloughs and side channels kind of have an edge or they end, that's where we consider the high bank. And from that, we also get some water seepage and spring flow coming into these systems as well, which help add to the diversity. So with that diversity, I kind of alluded to earlier, with that becomes our fish diversity. With the habitat diversity comes the fish diversity. And so what I did is over the last 20 years, I looked into our database. And from the last 20 years, I pulled out all the fish species that were documented in the lower Wisconsin Riverway. So that's going to be the lower Wisconsin River, all the named and unnamed sloughs, the side channels and tributaries that traverse across the Riverway. And there was 94, looked into our database, and I also pulled out some research reports as well that weren't in our database. And overall, there were 94 fish species documented that represented 23 different families of fish. That was over the last 20 years. And then if you look back into the late 1960s, early 1970s, it's as high as 108 different fish species that have been documented. Of the 94 fish species over the last 24 years, if you want to look at invasive or introduced species, there was the brown trout, the bighead carp, grass carp, and then also common carp would be ones we consider as far as introduced species go. So as everyday anglers or recreationalists, when we're out enjoying the outdoors and we're out on our Wisconsin waters, most of the species that we see and that we're very familiar with are the ones we typically catch hook and line. And so for the lower Wisconsin Riverway, when you look at the backwater sloughs, most of us will be catching panfish, yellow perch, bluegill, the crappies. You'll see some northern pike back in the backwaters as well. And then also on the main river channel, that's where we'll see our sauger or walleye, smallmouth bass, channel catfish. And also, for soaking night crawlers, you'll see a lot of red horse species, typically your shorthead red horse like you see on the bottom left photo, and then also freshwater drum as well. Back in the early 90s, when there was a creel survey done for the entire lower Wisconsin Riverway system, for the main river channel, walleye and channel catfish were the two most abundant species caught as far as anglers go. So these are the ones that we see and that we're familiar with. So what about all the fish species that we don't normally get to see? That's one of the nice things about the career that I have and the jobs that some of us work, is that when we're out sampling, we get to see some of these species that we don't normally get to see with that. And so to start out looking at some of the more unusual fish fauna, we'll start out with the American eel. So the American eel, while it's not a permanent resident of the lower Wisconsin Riverway, it is a transient. It'll come up every now and then as part of its life cycle. And to understand it, the one neat thing about the American eel is its life cycle. And so for those who aren't familiar with the life cycle of the American eel, they spawn out in the Atlantic Ocean, which there's an area, if you look at the lower right photo, there's an area called the Sargasso Sea. This is the spawning grounds of the eels. So after they hatch, the ocean currents will drift them. So they'll either drift towards North America or they'll drift towards Europe. And as they start to drift, they'll start to mature and grow and come into swimming phases of their life cycle. And they'll find their ways up freshwater tributaries. And for us, the freshwater tributary is going to be the Mississippi River, eventually finding their way to the lower Wisconsin River. The particular eel that you see in the photograph, this one was caught down by Bridgeport. This was been in 2018 during a catfish hoop netting survey. And this would have been on a Tuesday. And then on the following Wednesday, we had a second eel, which was a little bit smaller than this one that you see as well. So that was pretty neat. We ended up getting two eels back to back on two separate days. And that's something that we probably will never see again in our careers. But for those two eels that we found at Bridgeport in the Millville area, they would have migrated from their spawning ground somewhere in the neighborhood of 3,000 miles, plus or minus 500. So you're looking at 2,500 miles to 3,500 miles that these eels would have migrated from the spawning grounds. So they'll come up into the Mississippi River. We'll just talk about the ones in the Mississippi River drainage. They'll come up into the Mississippi River drainage, which includes the lower Wisconsin River. Somewhere in the neighborhood of 5 to 25 years, they'll live in these freshwater systems where they mature, and then they'll migrate back down. So those eels we caught will eventually migrate back the 2,500 to 3,500 miles that they came up to complete the life cycle of the eel. So that's really cool when you look at that. For Wisconsin, the eel, the state status is going to be special concern for this particular species. Going on to the next species. So this is probably the most recognizable species when you talk about unusual fish fauna in the lower Wisconsin River system. This is going to be the North American paddlefish. The one thing that I like to stress about the North American paddlefish is we currently have the only paddlefish species remaining in the world. So the North American paddlefish will be the only one remaining left in the world. The other one was the Chinese paddlefish, which has been now declared extinct. So it's probably more important now that we protect this particular species, being that it is the only species left in the world. The native range for the paddlefish is the entire Mississippi River watershed, which does include the Wisconsin River. The skeletons are primarily composed of cartilage, and with their big mouths and their gill raker complex, they are filter feeders. So they do swim around like you see on the bottom right-hand photo. They will swim around with their mouths open, filtering out plankton as they go along. And the rostrum, the unique thing, you know, the namesake of the paddlefish, its paddle or rostrum coming off of its face. Historically, it was thought to be used for digging or stirring up the bottom to find forage. But now we do know that it does contain many electrosensory receptors, which help for the location of prey items, but then also navigation as well, maybe. Here in Wisconsin, the state status is threatened. And if you want to see a paddlefish, they're primarily located on the lower Wisconsin River up at the dam, where we talked about the scour hole at the dam, which is kind of a slower flow, deeper water. And on active days, you'll see a lot of them jumping up at the dam. And some of them might just be active jumping. A lot of times it looks as though they're jumping to try throwing lampreys off their bodies. And if you sit up there long enough at the dam and watch over the water, eventually you'll see one come up and jump, and you'll see lampreys kind of cartwheeling off the body of the paddlefish, which is kind of cool for that. So sticking with some older species that have skeletons comprised of cartilage, we'll look at the sturgeon next. The biggest sturgeon we have is the lake sturgeon. This is one of the biggest species we have in Wisconsin that anglers can go out and catch hook and line. Fossils date back close to nearly 200 million years for this particular species. They are bottom feeders with diets composed of insect larvae, crustacean, mussels, dead fish. They can be scavengers as well. While sturgeon can get up over 100 years old, for the lower Wisconsin River, taking the spines off of sturgeon, the oldest one that's been recorded for the lower Wisconsin has been 45 years old with that one. And then also for state status, they are a special concern species as well. And if you look at the sturgeon, why they have, they get very large. The Wild Rose Fish Hatchery has a propagation program for lake sturgeon for the state. And if you look down on the bottom right photo, this is going to be a couple young of the year lake sturgeon from Wild Rose Hatchery when we were up placing pit tags in them. And what was really neat about this is why the sturgeon will have these large bony scutes for protection, or hard scutes for protection. The young of the year sturgeon, these guys are like rubber. They're really soft, pliable, almost rubber-like, so to speak, in regards to the way they felt. So that was kind of neat to be able to see those. And then plus you really don't get to see too many young of the year sturgeon in the wild. So having a propagation system, it gives us a chance to take a look at these guys. So going on to the next sturgeon species, we've got the Shovelnose Sturgeon. So this is the smallest species of sturgeon in North America. Again, just like the lake sturgeon and paddlefish, they have a skeleton that's composed of cartilage. They are bottom feeders. Again, looking at insect larvae, worms, crustaceans, scavenging on dead fish. For the lower Wisconsin River system, we've aged them up to 21 years old as far as the aging goes. And in growth, once they reach maturity, they're very slow growing. With the pit tags that we're deploying in these fish, we've caught some in the neighborhood of 5 to 10 years later after they've, or 5 to 11 years after they've been tagged. And these mature fish have only grown 0.1 to 0.3 inches in that 5 to 11 year time span. So they're very, very slow growing fish once they hit maturity. And the other unique thing, we've been sampling and looking at population estimates here, or trying to get population estimates off of them over the last 3 years. And the one thing we've noticed were a lot of deformities on some of these fish. And the one that really struck us was, like you see in the bottom right-hand picture there, was the one where they're missing their peduncle or caudal fin. And these fish are, even with this deformity, whether it was from an injury sustained earlier in life that they've healed from, or whether it was just from birth that this particular fish has had that deformity, but they seem to do just fine. Even with the missing most of their tail or almost a quarter of their body, they seem to keep trucking along really well, which is really kind of cool. And the other neat thing about these species is a lot of the fish that we work with, this particular species has come to grow on me the more we work with it. And I think a lot of reason of it is the way they look at you when you sample them. A lot of fish, when we sample them and measure them and weigh them and work with them, they just kind of have a dead stare off into space. But if you ever get up close and with the shovelnose sturgeon, if you're ever out angling and catch one, or even when you're surveys, just watch their eyes. Their eyes are constantly moving and looking at you and checking it out. It's almost like that fish is studying us as well as we're studying them. And so it's really cool and at the same time kind of eerie as well. But so it's a really neat species that we have here in the lower Wisconsin River. And most of the spawning for both the lake sturgeon and the shovelnose that we see will be in the upper rocky areas that we talked about before, and both species located in the main channel. Looking at a couple other different fish species here, the lampreys. We've got 2 species of lampreys, the silver and the chestnut, that will have, as far as the parasitic lampreys go, in the lower Wisconsin River system. With those, they live non-parasitic 4 to 7 years. So interesting thing with these guys is with their life cycle, once they hatch, they'll drift down, they'll burrow into the substrate, they'll live non-parasitic for 4 to 7 years before emerging. And then once they emerge, then they become the parasitic lamprey, kind of like that we know them, or we typically see them because they'll be attached to fish that we catch or sample. They'll be a parasitic for 1 year, and this is where they'll grow and mature for that particular 1 year period, and then they'll spawn the following spring and then die after spawn to complete the life cycle. So it's kind of an interesting life cycle that the lampreys will have here in the lower Wisconsin River system. Looking at the 2 species, this is a silver lamprey up on the upper left, the silver lamprey mouth. And so what a yellow circle is, if you look at their teeth, if you ever do get a lamprey and you look at their teeth, the teeth that line the mouth cavity will have a single or just a unicuspid teeth for the silver lamprey. And then if you look at the chestnut lamprey, it'll be bicuspid or have 2 points on the teeth, as you can see there in the picture up in the upper right. The bottom right picture, this shows a silver lamprey that had just emerged. We had talked about emerging and becoming parasitic. This particular individual was caught in late April, early May. So it kind of gives you an idea of the size of them coming out from their non-parasitic stage. They're fairly small. The next slide, which shows a chestnut lamprey on the left-hand photo, and you can see the snow in the background. This would have been in November, I believe, late October or November. And it kind of shows you how much they can grow in just that one growing season or within the year before they spawn the following spring. So this particular chestnut lamprey, this was found on Big Spring Creek. It was attached to a 21-inch brown trout, and you can see the scar on the top of the head of the 20-inch brown trout we'd taken. And it was located approximately 23 to 24 miles, I believe, upstream from the lower Wisconsin River. And so it was a Big Spring Creek is a tributary to Blue River, and Blue River flows into the Wisconsin River. So whether or not that particular lamprey migrated up the system and attached to the brown trout, or maybe it attached to the brown trout in the lower Blue River system, and then the brown trout gave it its ride up to the Big Spring Creek. So, but that was kind of a neat thing to see with the lampreys. A couple other species that we have going on to the gar species. So we have long nose gar and short nose gar. Both of them are common in the main river channel, but then they can also be found in the backwaters as well. Pretty easy to distinguish. If you look on the upper left, that's a picture of a long nose gar with its longer snout. And then also on the upper right, where we have a short nose gar as well, we can see it's just got a shorter, more stout snout to it. The long nose gar can get up to 4 feet or even a little longer on the lower Wisconsin River. And the short nose gar, we're usually looking at somewhere in the neighborhood of around 2 feet. A couple little tidbits for these guys: eggs are poisonous, and they do have a vascular swim bladder for air breathing to help supplement breathing via air breathing with that. And typically it becomes more important when we hit higher water temperatures with a little bit lower dissolved oxygen. The gar rely more on the gupping or air breathing when you see higher water temperatures, and they can drown. So we do have some incidental mortality every now and then in our nets when gar aren't able to come to the surface, particularly in the warmer months with that. So that's when we try checking our nets a little bit more often to help prevent that as well. And just like some of the other species we talked about before, fossils have dated back millions of years, so they've been around a long time, which is really cool about the gar species. And then they also have these really tough ganoid scales that were once believed to be used for tools and then also possibly weapons as well. In regards to angling for these guys, a lot of folks will use what they call a gar lure, which is basically a piece of nylon rope that's brushed out with a dog brush or a horse brush, real fine threads. And when the gar bites that rope, the rope will kind of look like a minnow dart into the water. And when they bite onto it, there's no hooks at all. All the teeth that you see in the bottom right-hand corner here of the gar, they'll get tangled up in the rope, and you're able to reel them in with that one. So, but the lower right's a picture of a long-nosed gar, just kind of showing you all the teeth that they have in their mouth. So you have to be careful whenever we're handling them. And that particular one has just over 200 teeth that we could count in that particular photo. So they do have a lot of teeth in their mouth, but they're a really neat species. The bowfin. So this is a species that's been getting a lot of attention lately from anglers. I think a lot of people are finally kind of realizing the neatness of this fish. They're found in the backwaters of the lower Wisconsin Riverway system, as well as many of our other river systems in the state and some of the lakes. But kind of neat things about these is the male will bite or fan or rub away vegetation when creating a spawning nest. They'll typically spawn in areas with a lot of vegetation because when the young hatch, they'll have an adhesive organ that they swim up and attach to the vegetation. This is kind of keep them off the bottom where it's anoxic. Just like the gar, they can also have a vascular swim bladder that allows for some air breathing and gupping as well. If you're ever out ice fishing, every now and then you'll hear reports of ice anglers reporting a bowfin coming up and gupping air through their ice hole and going back down. They do have many teeth, so if you do catch one, just kind of be careful of that. And they'll feed on fish, crayfish, worms, and large insects as well. Bowfin, they're really cool looking fish, and you can see like for the upper left-hand picture, the immature and the females will have this really cool mottled color, just real pretty fish. And the males during the spawn, the bottom right is a male that's probably getting ready to go into spawning color. They'll have kind of this bluish green color as well with the really neat eye spots. Both of the mature, immature, and the males and females, they all have the eye spot too on their tail. So they're a really neat fish. So the grass pickerel, this one I included on here because it's always fascinated me because it's kind of the mini-me of the musky and the northern pike. The maximum size is what you see here. It's usually only 8 to 11 inches. The largest documented one was close to 15. They are aggressive little predators. They'll feed on other fish, insects, and worms. And if you do catch one, to determine if it's a small northern pike or if you got yourself a grass pickerel, you can look at its gill plate. The gill plates will be fully scaled on the grass pickerel and only be half scaled on the northern pike as well with these guys. But they're typically found in the backwaters, the vegetative backwaters, and also the lower ends of the tributaries that come into the lower Wisconsin Riverway system. So I know a lot of folks are into the microfishing, like to catch these, and they're just a neat species to have around. So the catfish species, so this is my favorite family of fish, I guess, or the catfish. And so the two smallest species that we have here in the lower Wisconsin Riverway are going to be the tadpole mad tom, which you see on your lower right, and then also the stone cat, which you see on your upper left. So the stone cat, it's going to be found in the main river channel on gravel and rocky riffle areas, hence the name stone cat. And the tadpole mad tom we're going to find in the backwater sloughs with that. Both of these fish are indicators of healthy systems. I know in some of the more degraded streams, we really don't see any more stone cats or mad toms to speak of. So if we're finding stone cats and mad toms, we know we've got a pretty healthy system. And then also on the upper right picture, I just want to include it while it's a little bit out of focus. It's the stone cats on the upper, the fish on the top, and on the lower portion you have a tadpole mad tom, and that's kind of a neat picture because you can kind of see where they get their name, looking like a small black tadpole with a large head and slender body. You can kind of see the namesake, so to speak, for the tadpole mad tom. So these are pretty neat little pictures. I haven't really heard of too many people and even micro anglers catching these two particular species with those. So we'll go from the smallest catfish species that we have to the largest one, which is the flathead catfish on the lower Wisconsin River. This is my favorite species of fish as far as looking at all the different fish species. They can get fairly large. On the lower Wisconsin River, the largest one we have documented was 48 inches long, 4 foot and 65 pounds. The oldest one that we've got recorded for the lower Wisconsin Riverway has been 18 years. They typically going to be found in the main river channel associated with a lot of wood habitat like you see behind the smaller flathead catfish in the lower right photo. Some neat things about these guys is they basically have they've got pores all over their body, which are considered taste buds. They can have up to 250,000 or more located throughout the body. They're more concentrated in the face than the barbel areas, but it's helped pick up chemical compounds and other things that come in through the water, considered taste buds, so to speak. Another neat thing with the catfish species is that the olfactory system, in an olfactory system of fish, they'll have folds within inside their olfactory system or lamellae. Typically, if you're looking at your bass and bluegill and walleye, et cetera, are common game fish that we think of, they'll have somewhere in the neighborhood of 9 to 20 folds in their olfactory system. So for a catfish species, they'll have anywhere from 100 to 300 folds or olfactory lamellae, and this allows them to pick up, parts per billions of chemical compounds in the water, so they're pretty sensitive for picking up things. And then also in regards to a large flathead catfish, when you pick them up, they'll have some louvers, so to speak, located around their olfactory openings that allows the water to also funnel into their olfactory system to concentrate it even more. It's kind of a neat system. But then also the skin, if you ever get a flathead catfish and take a really good close look of its skin, they've got this big, thick, gelatinous coat for protection, and it's almost like a double layer skin. If you ever get close and look at it, it's really cool looking. So from the flathead catfish, we'll go to some of our sunfish species. This one's the orange spotted sunfish. This is going to be found on the backwater sloughs and lakes. They typically prefer the heavy vegetation when we see them in their samples. That's to help escape predation, and you can't miss them whenever you get an orange spotted sunfish. This is probably one of the more pretty sunfish we've got in this area with all its orange spots and its iridescent blues and purples. It's a really cool looking fish, and then the fins can get bright orange as well. The males during spawning, not only do they use their color to attract females, but they can also make a clicking or grunting noise too. Kind of a little tidbit for these guys that help attract the females to their nests. So, and that's about the maximum size you see. They'll fit in the palm of your hand there. They're pretty small sunfish species. They don't get much bigger than that. So next species, looking at the warmouth. This is one that we don't really see too often when we're out fishing. It's found in the backwater sloughs and the lakes as well. It can really vary in its color more for appearance. You can see in the upper left where you get the really nice dark black, blue, purple color with it, and then you also have kind of the bronze color, or bronze yellowish orange colors that you'll see on the bottom right. So one thing with the warmouth is they can withstand some lower oxygen levels, particularly in the backwater sloughs and lakes, compared to some of the other species that we have with that to let them hang around. So going on to the sucker species here, the lake chub sucker. This is somewhat of a rare one. It's special concern here in Wisconsin. It's found in the backwaters, the backwater sloughs and lakes here on the lower Wisconsin Riverway system that we'll see in our samples. And it's decreased or disappeared throughout much of its range. And a couple things for that is it's not tolerant to a lot of pollution in the water as far as nutrient runoff, et cetera. So the water quality degradation has led to its decrease in a lot of its range. But then also sport fish management, to where we're introducing predator fish such as largemouth bass, flathead catfish, walleye. When these species get introduced into systems, a lot of times these sport fish will be introduced, and you'll have non-game fish species that aren't used to competing with these predator fish that you'll start seeing in decreased abundance. We'll see the same thing here in Wisconsin a lot of times when we move game fish around. So that's something that we should be aware of. But that's the Lake Chub sucker. Probably the most popular sucker we have on the lower Wisconsin Riverway is the blue sucker. I think probably because it gets the largest size. It can get up to 30 inches long and 10 pounds. They typically live in the main river channel. For Wisconsin, they're only found in the Mississippi River drainage. And for the lower Wisconsin, most of the spawning appears to occur in that upper reach where we talked about that rock, sand, gravel area. With that, the state status is threatened, so you don't see too many of them. Anglers are reporting catches of them. We're currently doing a creel up by the Prairie du Sac Dam, and we do see anglers reporting catches for all things fishing for walleye. They're using jig and minnow, so the blue suckers might be scavenging up the dead minnow on the jig with that one for anglers catching those. So that's the blue sucker. Looking at some darter species, the mud darter, which is found in the backwater sloughs and lakes. With that one, the males will display bright colors to attract the females. And because of its scarcity and being able to study it, little is known about the life history habitat requirements of this particular species. The state status for Wisconsin is special concern. The upper one, the photo taken by Dave Marshall, that's a mud darter out of one of our backwater sloughs and lakes. You can kind of see that it's a little bit darker to adapt to the color variations. And then the bottom right one is from the Tennessee Aquarium, and it kind of shows you how bright and colorful our darter species can get here in the North America and the Midwest. Another darter, this one is state endangered species, the crystal darter. It's found in the main river channel. It's thought to inhabit the deeper riffles and gravel and sand. And it might be why we don't see too many of them. If they're deeper to where our sampling gear doesn't really get to them, might be another reason we don't see too many of them. So this is a really cool darter species, kind of a neat looking species. This is probably one of the best photos that I've seen of a crystal darter. It was taken by Kimberly Kuber and then Jim Amorine. I think it was 2019. This one was sampled down by Muscadet. But yeah, we've seen them when you look at our samples that were taken from the lower Wisconsin Riverway, like 2009, 2012, and then 2019. So they show up in the samples every now and then, but they're not very common. Starhead top minnow. So these are found in the backwaters of the lower Wisconsin Riverway. So they got the upturned mouth for feeding towards the surface of the waters. They get their name to starhead top minnow. If you look at the lower right photo, you can kind of see the silver or white spot that occurs in between on the forehead, in between the eyes, or the star, so to speak. They are state endangered. Like I mentioned, they're found in the backwater sloughs. And Dave Marshall, along with some other retired DNR employees and volunteers, are raising these fish, and they're transplanting them up above the Prairie du Sac Dam into some more suitable habitat, and they are taking hold and expanding the range. So that's kind of a success story and a project that those guys are working on as well, which is kind of cool to see for a state endangered species. So if you're ever along the backwater lakes, just right along the bank, these guys will be right up along the bank, darting in and out of the vegetation. They're really easy to see and they're really easy to identify. Like I said, they'll have the white spot right on the top of their forehead. So if you're ever walking right along the bank on one of our backwater sloughs or lakes, just kind of keep your eye out for the small fish darting around towards the surface, and you can't miss them. They're pretty cool looking for those. This will be the last fish that we talk about today. This is the pirate perch. So it's found in the backwater sloughs and lakes, and also on the lower ends of the tributaries here in the lower Wisconsin Riverway system. The claim to fame for this species is its anatomy. So if you look at the arrow, most fish, and even with the pirate perch when it first starts growing, it's got its vent for its waste and gametes that starts back in the normal location over most fish species. But then as the fish matures, it ends up migrating forwards to in between the gills, just right up here and just below the mouth, and in between the gills is where the openings end up migrating to. And so for many years, it was thought that maybe it was a mouth brooder, or why do the gametes, for expelling the gametes located this close to the mouth. One of the guys I went to school with, Ed Wetzel, if you see him in publication reports, his name will be James Wetzel. They happened to catch it in a video in an aquarium where they had a male and female, and so the gametes were taken in by the gills and then expelled through the mouth. So they were kind of blowing out the eggs and the sperm during the spawn, and I think they call it like transbrachial spawning, which is kind of a unique thing to this fish, and in particular for fish that were found in our area. So this is a fish that we don't normally see. They're fairly abundant, but you really don't get to see them too much just because of the habitat that they live in with it. And then the upper right picture where the circle is, that kind of shows you again where their vent's located up towards the upper end of their mouth. So it's just kind of another unique fish species that we have here in Wisconsin, and also associated with the waters in the lower Wisconsin Riverway as well. So it's kind of neat to see with those. And with that, that is the end of the fish species that I had to present today. This is kind of what it looks like when you're on the lower Wisconsin River with all these different fish species and they're not biting. So that's what we get to see. So with that, thank you very much. And then just like I said, just the lower Wisconsin Riverway is a fantastic water resource, and hopefully we'll be able to protect it for years to come.
Thank you, Brad. Yeah, I guess you never know what's going to take down your bobber when you're out fishing. There's some amazing biodiversity under the water here in Wisconsin. Looks like we got just a couple specific questions for you. The first question here, are there any, so you talked about kind of the toxins present in gar eggs. Is that relatively unique, or are there other species of fish that have similar properties? I know this person mentioned they've heard people eating eggs of perch and bluegill and walleye pretty frequently, but are there other species that have that?
Yeah, when I was putting together this talk, I did look at other species that we were looking at, and the gar was the only one that they mentioned that having that toxicity. Mm-hmm. So, and then you would think that maybe even bowfin would have that, but there was no mention of it. So yeah, the gar was the only species that I came across that they'd mentioned it in the literature for having that.
Wonderful. So avoid that, everyone. So you mentioned with the pickerel, the scales on the gill plates. Are the scales just like those on the main body, or are those scales different?
So they'll be similar like they are in the main body. They'll be a little bit smaller. You know, when you hold them and look at them, they'll be similar, but just of a smaller size. And they are kind of hard to see when you look at the scales on the grass pickerel compared to the northern pike. The northern pike, the bottom half of the gill plate will not have scales, but the scales are so small. It's you know, as you get older, you almost need a magnifying glass to look at them. But you know, it's for younger folks, it's fairly easy to see.
Wonderful. Well, we've got a couple minutes. I might just ask one of my own questions. This is more just kind of an opinion question, Brad. I know we often see certain species prioritized, maybe based on how good they taste, or something. You know, we really talk about protecting and stocking walleye and certain panfish and pike and musky. And it seems like a lot of these amazing fish are threatened or of special interest. What do you see like the role of, you know, anglers in bringing about some more focus on other species, or do you see a kind of philosophy changing anytime soon on what fishes we agree are valuable as a community? You know, I think that's something that I'm really interested in.
Yeah, I think there's two things there. I think the more research that's done in regards to fisheries science, we definitely see a focus on more of these species and the importance they have in the ecosystems. But then also from an angler perspective, we see more anglers looking for unique species or additional species other than just kind of like the bass, walleye type complex or panfish. And then there's a contingent of you know, what we consider micro anglers, where they're using micro size hooks to catch different what we consider non-game species. So for the growth of for the growth of micro angling, and then also anglers that are exploring these backwaters with kayaks and canoes and going after these unique species, we're seeing the popularity grow. And with popularity is going to be interest, and with interest is going to be protection, that's hopefully what we'll see. So, and then we're also seeing, not necessarily in Wisconsin, we have the propagation for the lake sturgeon, but then other states, you'll have propagation also for paddlefish as well, which is kind of nice to see for helping keeping that species going.
Fantastic. Yeah, I know I've only seen a couple of those species in person myself. I'd love to see all of them one day. Well, with that, Brad, thank you so much. That fills up our time this morning before our next session. I really appreciate you sharing your knowledge with us and talking about some of those amazing fish out in Wisconsin. Thank you very much.
Thank you very much for having me.
Absolutely. And to all the people viewing, make sure to join us after our break here. We will have a break until 11, but we will be visited by John Lyons to talk about invasive species. So make sure to tune back in. And I hope everyone is enjoying some amazing presentations across the board this week. Thank you very much.